Today we are going to discuss about upsampling or interpolation. So increasing the sampling rate of a discrete time signal is referred to as the upsampling. So when we try to increase the signal rate by the amount of a particular factor, that factor here represented here as a symbol called I. If we increased a factor by an I, then they are referred to as the upsampling. Mathematically, it is given by a notation y of n is equal to x of n by I. Here I indicating the number of n indicate the number of input signal samples in the input signal, followed by I indicate the factor in which it has to be upsampled. And the same is depicted in the picture x of n, y of n, followed by upsampler by a factor I. So the same example I have taken here, x of n is equal to x of 1, 2, 3, x of 1, 2, 3. So now what are we going to do is nothing but we want for an upsampling by a factor of I is equal to 2. So what do you mean by that? At every regular intervals of time period 2, that is 0, then 2, followed by 4, then 6, every interval has to be upsampled, right? So we will go and see what is x of n and what is x of n by 2 as well as x of n by 3. If x of n by 2 is nothing but it takes the given input signal x of n, the 0th sample, as it is. Then the next sample it is ignored, okay, and it put it as 0, and the next sample is 2, then 0, then 3, then 0. That is every in between signal, it is a means of adding zeros. N by 3. Every third sample, the input signal will be written, whereas the subsequent samples will be made as zeros. Clear down? Okay. So using anti-imaging filter is used to kept after the upsampler to remove the unwanted images developed due to overlapping. So there we used anti-aliasing filters. Here we are using anti-imaging filter. The reason is nothing but to remove the unwanted images that reflected back in the signal. It's a filter, and upsampler is referred to as the interpolator. So it is nothing but the process of increasing the signal by a rate of I samples between the successive signals of the given input signal. Figure shows the given signal x of n, and it is 2 fold up as well as the subsequent form, right? Sampled signal y of n and followed by interpolation of y2 of n. So x of n is given, right? X of yn and x of 2n. What is x of y1 of n? Which is nothing but upsampled by rate of n by 2. Y is equal to x of n by 2, and y of 2n is equal to is nothing but x of n by 3. So there it is given as a sequence of 0, then 1. You can see here 1, then we have a 0, then we have a 2. Similarly in the diagram it is made. The remaining other samples are made with the discrete sample value as 0. You could also infer that from y2 of n also. Every third sample the signals will be written, whereas all the other samples signals are totally removed from the analysis. So block diagram of an interpolator, if you want to mention it, it is nothing but anti-imaging filter, upsampler followed by and interpolation filter. So there filters are kept before the downsampler. Here the filters are kept after your upsampler. So any expressions if you want to mention with respect to the output of an interpolator, that is nothing but an integer factor which is sampled by a time period t. So let t be the sampling time period and f be the frequency. F will be equal to I 1 by t. After we upsample, that is the new sampling period t and the new sampling frequency then will be denoted by t dash by t is equal to 1 by I. Then the sampling rate is given as f. We know f is equal to 1 by t dash, which is nothing but 1 by t, I by t. So I by t is nothing but I is a factor and 1 by t is nothing but f. So it is IF. So sampling rate is normally given here is nothing but what? Your f dash is equal to interpolation factor I into the original frequency f. Thank you.